Okay, good morning, everybody, and thank you so much for joining us on this beautiful Thursday, July 15 of 2021. On behalf of Old Dominion University, welcome to REYES, Remote Experience for Young Engineers and Scientists. My name is Nestor Escobales, and I am a Master Lecturer in Engineering Technology Department here at Old Dominion University. I am a licensed professional civil engineer, or PE, with primary focus in structural engineering. I completed my undergraduate education at the Polytechnic University of Puerto Rico and my graduate education at the University of Illinois at Urbana-Champaign. My areas of interest are pre-engineered metal buildings, collapse investigations, and structural mechanics. This presentation is intended for STEM majors. STEM is short for science, technology, engineering, and mathematics. This session deals with experimental testing of metals in tension in a virtual setting. Engineers are required to design safe and economical structures, and for this we need to understand the mechanical behavior of the elements that we use in design. This knowledge helps engineers make better decisions when deciding which cross-sectional shapes and materials are to be utilized when subjected to different types of loading conditions. It also allows us to understand material behavior like brittle or ductile behavior. We will start in a few seconds with the presentation, and in about 30 minutes or so, I will switch to questions from the audience. However, feel completely free to start sending your questions as you are listening to the talk. I will answer to as many questions as possible. So you should be able to see on your screen the Blackboard account for REYES. And here on the left side, we're going to be able to see a number of folders. We got information, thermodynamics, materials, fluids, Excel, Python, and a help. We're going to be essentially looking at the material testing laboratory. And another thing that I wanted to mention in here, in the chat, I posted a link that I need you to copy on your personal computer. So copy that, paste it on the browser, and that is for access to Blackboard so that you can be able to access the account and be able to review the information that I am talking about here today, and also view some videos. The laboratory, the tension laboratory, takes a little bit more than an hour. So there's a number of videos, pre-recorded videos that I would like you to review. One of the questions that we are asked constantly is how do we go about completing laboratories in engineering in an online setting? And so many of you would think that we would do laboratories only in person, and certainly that's how we started. At some point in time, when we started developing the laboratories, we would do everything in person. And as time has been passing, we have been evolving, technologically speaking. And so we are doing a lot of more things online. We take advantage of the technology so that we can reach further and be able to help those that are not on campus, those that are working full-time, even military students that are deployed but want to continue their education, and they are able to do so by means of technology, internet access, and the use of the pre-recording that we do. And so in our classes, we teach our classes live, but we record our classes and we save those videos, and those video archives are available to those registered in the classes. And then you can come in and review the class and take the notes and be able to access the homework, the projects, the exams, etc., everything online. And the classes are exactly the same, whether it's in person or online. So there's really no difference. So you will be essentially exposed to the same type of challenges than somebody that is going to be on campus face-to-face. And so we strive to improve the quality of the videos and the quality of the assessment process. And so that over time, it has reached a really good level of quality. So we are always looking to improve the system that way. We do internal audits between faculty members, chairs, and we also take recommendations from the students themselves. There is a student opinion survey on all classes that we conduct at the very end of the semester, and we read through all of those questions and comments from the students, and we take that into consideration to make any potential changes and improvements in what we are teaching. So Blackboard is a communication tool between the student and the faculty member, and it is set up for each class. So each class has a Blackboard account. It's independent from one another. When you're registered, you will have access to 4 or 5 different accounts. Each one would represent a class. And the faculty member, they post announcements, folders that are associated with lecture notes of the class or handouts. The homework assignments are posted there, and exams can also be given via Blackboard in a sort of online setting, but they can also be assigned in person, and you don't necessarily have to be here on campus. You can take the exams in person at your location. So I'm telling you all of this so that you can see the relationship between what we are presenting here today and how we do things in our college. We have a Blackboard account for REYES, and we are doing the fundamentals of engineering, and we have 3 main subjects in here: thermodynamics, the material testing, which is more related to strength of materials, and the fluid mechanics laboratory. The other folders that we have in here are things that we thought you would like to review: the Excel videos and readings that are recommended for engineering students, and Python for physics, which is a programming language that is more recent, we can say. And so we thought that you would, if you are an engineering student, you might be interested in reviewing those. So feel free to navigate through those folders. If you have any issues, there's a help section in there and contact information. You can also, if you have any issues, contact the REYES team. If you go to the REYES webpage, there is a email in there for any questions that you may have or issues that you may be facing while trying to access our links and files. So from the chat, copy the link, and that is for access to Blackboard. And if you run into any issues when you are loading that page, try a different browser. We have received information that using different browsers can potentially help you access Blackboard a lot easier. Okay, so I'm gonna post the link again. 1 second. Let me search in here. Just a second, please, while I chase down the link. Okay, so I posted again the link on the chat. You should be able to access that. Let me know. Let us know if you have any issues. Again, if access does not occur immediately, change the browser. Use a different browser. There are different types, Chrome and Firefox. Microsoft has another one. So Microsoft Edge. So try different browsers, and that would allow you to access. So let's go to the tension test folder. And at the moment, I would certainly ask you to follow along the lecture, and so any other issues that you may encounter, then let's tackle those separately. So we're gonna go through these folders in here. So at the top, you should be seeing the Tension Lab presentation, and then there is lab overview, and that is number 1. 2 is equipment and materials. 3 is aluminum test. 4 is cast iron test. 5 is low alloy steel test. So essentially, in lab overview, I will be inside the laboratory, the material testing laboratory here at Old Dominion University. And I will be giving you an overview of all of the specimens and all of the different tools, instrumentation, and the equipment that is used for this particular test. That video in there is 5 minutes, 54 seconds. So they are relatively short. If you go to number 2, is equipment and materials overview. I want you to, after we conclude the presentation today, I want you to click there. When you click there, there will be another video, and then you will click play and watch that video. And you're going to be looking at information about the equipment and the materials overview for this lab activity. And then after that, there will be 3 tests. Those are independent tests, number 3, 4, and 5. The first one is the aluminum, the second one is the cast iron, and the last one is the low alloy steel. It's a low carbon steel material. So we have 3 types of steel in here, which from our experience, we know they have different strength or stiffness. They are certainly mechanically different from the standpoint of how can we bend those materials, or how can we apply any type of loading to those materials. So this tension test is going to give us an idea of the internal behavior of the three types of materials. So let's go over the presentation. So you should be able now to see the tension lab presentation. And so we are going to go over an agenda of items in here. Goals and objectives, who takes the lab, what is tension, what examples of tension in the real world, or what are examples of tension in the real world, what are some of the materials that can be tested in tension, what mechanical properties can be derived from a lab tension study, what equipment is used, what cross-sectional shapes are better suited for tension, what equations are applicable, what is the difference between theoretical and experimental, collecting and processing data, which is one of the most important parts in a laboratory. And then I will assign a homework. So I'm going to give you a challenge, and hopefully I will receive responses from some of you. In the past, when we have given a homework, we have been pleasantly surprised to see people from different points of the world, parts of the world, attempting the homework and doing a really nice job. So I certainly would like to see if you can take the challenge, which, by the way, reminds me of giving you my email. So my email is nescobar@odu.edu, and that's where I would like you to send the homework, the completed homework. So let's go in here and continue. So goals and objectives. We want to understand concepts related to tension of metals. We want to study mechanical properties of metals in tension. We want to research online. We want to apply concepts learned here to collect and process data. We want to develop a graph that shows the behavior of metals in tension. We want to interpret results and derive conclusions. So those are our main goals and objectives for this particular laboratory. So who takes this laboratory, the material testing laboratory? Certainly this particular test is set up for engineering technology students. However, a slight variation of this test is done for engineering students, and there's a difference between the two. And for that, I am providing a separate presentation that I would like you to review, which is about the civil engineering technology program. That one is on Blackboard as well. And before we go today, I will show you exactly where that one is at. But one program, engineering technology, is more practice and oriented. It's more project-based type instruction. And the engineering side is more science and theoretical. So there's some difference between the two, even though the end goal is to become an engineer. And both programs at Old Dominion University are accredited by ABET, which is extremely important. So this particular test is, or lab is taken by civil engineering technology and mechanical engineering technology students. Okay, so what is tension? And we want to talk about tension from the structural standpoint, specifically speaking, or talking about. So we have various types of materials, and we have them in some shape. That shape is a reduced cross-sectional area away from the ends. So the ends are much larger than the interior of the material. It's the same material throughout. We call that a dog bone essentially, because it resembles the shape of a bone, where the ends are wider, thicker than the interior. And there is a reason for that. If we clamp the ends of this specimen, then we want to make sure that it only fractures in the reduced area. We don't want the material to fracture at the place where we are clamping the specimen. Think of the fact that we're going to apply a tension force. So if we use a material that is of the same cross-sectional area, no changes in the thickness or diameter of the material, then it is possible that it may fracture where we are holding the material at the ends. We don't want that to happen. We want it to break on the interior so that we can study that portion of the material. Essentially, a tension test is taking an element and applying an axial force away from each other. So it's the same magnitude force applied in opposite directions. And the case that we are studying in here, it's a dog bone shape specimen. The test is called uniaxial because the force is passing through the centroidal axis of the bar. What are the examples of elements in tension on the real world? And so here we have a suspended indoor track with steel rods. So I'm sure that at one point in time or another, you have visited a recreational facility, a gymnasium, and it may have an indoor track. This track is elevated. You have a basketball court below, and so people walk or run along that area. Now you want to leave the track open so that you can view below. And so how are we going to accomplish that and support the track up, vertically speaking, the floor of the track? Well, we can do that by providing cables at different points. So we have these support or lifting points around the entire perimeter of the inside of the track. And so that is a cable in tension. And so those are steel rods, essentially what we have in there. Other examples in hotels, you may see this. You may have an indoor suspended walkway, and that one is suspended by tubes in this case because the loads are considerably higher. Perhaps the span of the walkway is a little bit more. So that one is an element that has tensile forces. So it's essentially lifting or keeping that walkway in equilibrium, in place. Right now, there's nobody in there, but we can have a lot of people walking around. And that's really very important, that it has to have very good connections and elements sized correctly and the proper materials used. Another case in here, this is a pedestrian bridge, but it has a truss. The truss is a open web beam, essentially, that has a top chord, a bottom chord, and diagonals. Some of the diagonals are going to be in tension, some of the diagonals are going to be in compression. And so that is another example of a system that has elements subjected to tension. And those are square tubes. What are some of the materials that we can use in tension? Literally, we can test everything in tension. We have alloy steels, aluminum, brass, bronze, carbon steel, cast iron, stainless steel, fiberglass. We can even test plastics if we want to. But the reason of us testing different materials is so that we can understand the mechanical properties, and then allows us to make decisions as to which materials we need to use for which applications. We are not going to necessarily use the same material for all applications. Some materials are heavier than others, and some materials are more expensive than others. So it all depends on the availability, the cost, and the application. And so that's what is going to make a difference in terms of which material we are going to end up using. What are the mechanical properties that can be derived from a lab tension study? Well, we learned about a modulus of elasticity, which is an important property of the material that allows us to know at the point at which the material ceases to become elastic. So what is an elastic material? Well, if we apply tension to a material and we see the material is stretching, elongating, and so that tells you about the properties of the material itself. You are able to elongate. But what happens if we remove the force? If we decrease the force or remove the force, then the material goes back to its original position. Well, if we do not exceed the modulus of elasticity or the yield point of, let's say, the yield point of this material, then the material can go back to its original position. But if we exceed that limit, then we go into the plastic or strain hardening. We plastify the material. When we remove the force, then the material will have a permanent deformation. The modulus of elasticity is the point at which any application of load, loading on unloading, remains elastic. And so it is the slope of the stress strain curve, as we will see later on. The Poisson's ratio is a ratio of axial strain versus lateral strain. So it has something to do with the fact that we apply tension to a material, and as we apply that tension, the material shrinks. And if we were to apply compression to the material, we can see that the material increases in cross-sectional area. So instead of shrinking, it expands. So Poisson's ratio is that effect. Then the ultimate tensile strength is the maximum stress that the material can take. Yield strength is the point at which the material ceases to become elastic, and the proportional limit is that particular point that has that limit of between elastic and plastic. Ductility essentially is the ability to undergo large deformation before the material fractures, and the stiffness is that resistance that the material possesses.